Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Duckworth Jr., mathematics instructor at the University of Liberia and your math tutor. Today, I will be looking at differential equations and type 2 of variable separable method. So under type 2, we said if you have a differential equation that you cannot easily separate the variables, then you look for some other expressions within the differential equations that could be substituted so that the differential equation can be a variable separable differential equation. So that's all about type 2, which is reducible to variable separable method. So we have this differential equation question 42, x plus y minus a, x plus y minus b, dy by dx equals to x plus y plus a, x plus y plus b. So if you were to just cross multiply or you expand this thing, and then you try to separate all of the x and all of the y expressions, you might get difficulty in showing that all of the x expressions are separated from the y expressions. So we could also substitute x plus y with a new variable. So you will have an expression right here now in just one variable instead of having this expression in two variables. So we say let u equals x plus y. So since u is a new function, y is was the initial function in the problem. So we're now differentiating u and y with respect to x. So we have du by dx is equals the derivative of x is 1 plus the derivative of y is dy by dx. So we want to solve for dy by dx by just sending this 1 across. So we have du over dx minus 1 is equals dy by dx. So we go back to the problem to replace. So that's where we see x plus y, we're going to put u. So this dy by dx now is just equals to du or over dx minus 1. And then on this side is just u plus a over u plus b. So we want to get rid of, all of these denominators and everything. So we could first say, let's get rid of this u minus a, u minus b. So to do that, we could say we multiply this entire expression by the reverse of this, which is u minus b all over u minus a. So if you multiply this by this, u minus a will cancel u minus a, u minus b will cancel u minus b. So you're just going to have du over dx minus 1 on this side of the equation. Because this time this will cancel and this cancel. Equals, so this time this, you're going to have u plus a times u minus b all over u minus a or u plus b times u plus b. So again, we can send this 1 across and expand this. So we have du all over dx is equals, so it's u squared, u times b is bu au ab all over u squared bu au and ab plus 1 when this 1 goes across. So find LCD. So we have du by dx equals, so the LCD now is just u squared plus bu minus au minus ab. But right between here, this bu and au, we can do some factoring by grouping right here. So let's just leave that and continue. So we have u squared minus bu plus au minus ab plus 1 over 1. Now, the LCD for 1 and this entire expression is just this time this, which is just this. So you want to now say this first denominator goes within this LCD, is just 1 times. 1 times the numerator. So it's u squared minus bu plus au minus ab. That's the first one. The second one, 1 into this denominator, it goes there, this entire denominator times that one. It's just the same thing. So it's u squared plus bu minus au minus ab. So we see how best we can simplify. Au minus au go out. So bu and bu go out as well. So we're going to have du bar dx equals u square minus, so u square plus u square is 2u square, and then ab minus ab minus ab is 2ab divided by this. So it's u square plus bu minus au minus ab. So we can cross multiply now. So we're going to have du, so it's this time this, so it's u square plus bu minus au minus ab du equals 2u. Now we can factor out 2, so it's u square minus ab dx. But because this is x, we don't need an expression with u, so we must divide both sides by u square minus ab, u square minus ab. So u square minus ab will cancel. Now we'll be left with u square plus, now between here we can factor out u, so u can be factored out. So we'll be left with b minus a minus ab du all over u square minus ab equals to 2 dx. So because the variables now have been separated, we can integrate both sides to find our general solution. So to integrate the left-hand side, we have the integral of, now the first term and the last term, we can group them. U square minus a square. And we're going to express it over this denominator, u square minus a square. So we say du plus, so the second term, which is b minus a u over the same denominators. So you know that when the denominators are the same, you can just take one of them and add a numerator. So we just open them up. That's all. We didn't change anything. So the derivative of 2 dx is just 2x. So we continue. So in the first term, this will cancel this one. So you will just have the integral of du plus, now because we have u right here, now let's bring that b minus a outside. We're going to have the integral of u all over u square minus ab equals to 2x. So we know that if we say let some variable t equals to u square minus ab, if we differentiate u square minus ab, we can get u. So we say dt now equals to 2u du. So we just need u du. Or if we like, since we already seen 2u du, we can just rationalize 2. So we need a 2 right here. So we can just bring the other 2 down here. So you see 2 times 2 divided by 2, it can go out. So we just rationalize 2, that's it. Or you divide both sides by 2 and then you just solve for u and du. So that's where we see 2u du, we're going to write the t. So this is now u plus b minus a all over 2. So the integral of dt all over t all equals to 2x. So the integral of dt all over t is just the ln. So this u now is x plus y, remember, plus b minus a all over 2. The integral of this is just the ln of t all equals to 2x plus some arbitrary constant c. So x plus y plus b minus a all over 2, the ln of t. T is just u squared minus ab, all equals to 2x plus c. But what is u? So we got x plus y plus b minus a all over 2. The ln of u was x plus y from the initial stage minus ab, all equals to 2x plus c. So if we can further simplify it to get our final answer. Just to simplify it a bit, so we'll get rid of this denominator by multiplying all sides by 2. Just to get rid of this denominator down, yeah? So we're going to have like 2x, 2 times y, we're going to have 2y, 2 times this one will just give us b minus a, the ln of x plus y all square minus ab, all equals, now 2 times this is just equals to 4, plus 2c. So this 2x, and then this 4x. So we know that if we deal with these two, what we're going to get. So this is now 2y plus b minus a ln of x plus y all square minus a b all equals, now 4x, if that goes across, it becomes minus. So it's 4x minus 2x. So it's just equal to 2x. So this is now 2x. Plus, now this 2 arbitrary constant c, we just represent it with another constant because it's still a constant. If you differentiate 2c, it gives you 0. You differentiate a, it gives you 0. So it's still a constant. So we could stop here, or we could say let's send this term across the equal sign. Whatever we want to do is just to be playing with the problem, but it's okay already. So we can send this expression across the equal sign. We will have 2y equals to 2x minus b minus a ln of x plus y all square minus ab plus arbitrary constant a. So we want to solve for y, we're going to divide all sides by 2, just by 2. So finally we will have y to be equal to x minus b minus a all over 2, the ln of x plus y all square minus ab plus, now this a over 2 is the same thing, we just rewrite it as a constant, so we're just going to replace it with c, or we can say d, or we say the same a, whatever we want to replace it with. So this is the general solution of the differential equation using the type 2 of variable separable that we call reducible to variable separable method. So thanks ever so much. Please don't forget to subscribe to our channel.